I wanted to draw the attention of people in the Brisbane, South-East Queensland area who want to have solar but who are limited and can only really have panels on a south aspect or have to include the south aspect. This is really quite an amazing document put together by the Clean Energy Council. So you can, this is cast iron correct. And this is really surprising to show how often the loss of efficiency is far less than you'd imagine. So I'm going to give an example here, but there are two factors here. One is the plane inclination. Now this is the angle of your roof, you know, the pitch. I mean, most roofs are like 20 degrees. I mean, you're not going to have that. Some roofs are flat. And this is the plane azimuth, and I'll need to show an example in order to understand this. You'll see how it goes from 0 through to 150, because then it's back to 0. So if you look at this, this term here, the plane azimuth. So if this house I used as an example isn't facing due north, this roof isn't due north, it's kind of facing northwest. If it was facing exactly like this, facing due north, then the panels would be 0 degrees off the plane. It's maximum efficiency. Due east would be 90 degrees off the plane. Due south 180, due west 270. So if we wanted to put panels on this southern roof, you can see that it isn't due south, because it's actually facing south-southeast. So looking at a figure there between 90 and 180, that's around, this aspect pointing this direction is about 160. So this is actually, if we had to put panels here, this would be more efficient than if the panels were due south. So if you keep that 160 degrees, and let's call this pitch here 30 degrees. So keeping those figures in mind, plane azimuth here 160 degrees, because it's southeast, and if we work on the plane 30 degrees, you'll see that the efficiency is 71%, which is less than 30% less than if it was just facing due north. So this is where it gets interesting. So if it was due south, you'll see, if that roof was due south, you'll see that comes down a bit to 69 degrees, and the steeper the pitch of those panels on the south, the bigger the drop in efficiency. So if you had some incredibly steep pitch roof, 70 degrees at 180, see these are as low as the efficiency gets. But for nearly everybody else, it's much better. So if you look at 160, with this aspect here, 160, and say 30 degrees pitch, then basically it's 72% efficiency. So you think, well, okay, that's quite a big loss of efficiency, but the thing is, in Australia, you can have 33% more panel capacity than inverter capacity. That's why for a 5 kilowatt inverter, you're allowed to have 6.66 kilowatts as maximum. That's 33% more. So that extra capacity takes care of all the inefficiencies in the system, including this drop in efficiency, because we have some southern facing panels. And for a lot of people, you wouldn't just have panels on the south, you might get them on the east and the west, or maybe some on the north, which means if you look at the proportion of, if you have, you know, let's say you have half the panels on the south and half on the north, then this loss of efficiency would be half, because only half of the panels are on this southern aspect. So this loss of efficiency won't be for all the panels if some of the panels are on another aspect. So you'll see the loss of efficiency is far less than you'd imagine. So I thought this document was really excellent. And I read an article in the Weekend Australian some months ago, really interesting article saying that where the journalist had done the research and saying, well, you know, sometimes panels on the south make perfectly good sense. So loss of efficiency, it could even be less than that extra capacity you've got between your panels and your inverter. So your inverter can only handle so much. You can't fit a quart into a pint pot. So that 33% extra overclocking on the panels will take care, by and large, of this inefficiency with the southern panels. So this is a really good document, and I just thought I'd share that with you. If you have any comments or you have any questions, just let me know.